Good afternoon. Welcome to lab number 2. Today, experiment will be conduction through a series of metal bar. But first, let me go ahead and explain to you the setup that we have here. So we're using a ARMFIELD set of equipments. This one here is our ARMFIELD HT11C. Then we have our ARMFIELD HT10XC computer control, which transfers all our data to our ARMFIELD software. Now in today's experiment, we have the option of running manual or remote by just a flick of a switch. We're going to be doing our experiment today remotely, meaning all our data will be gathered through the ARMFIELD software. Now, before I begin, I'm going to tell you a little bit about the HT11C. So, what we have here, you're seeing 3 different sections, and these are for different experiments depending on what you're actually trying to achieve. And these are sections that are interchangeable. And when I say interchangeable, what happens is that this section can be unclamped and removed. So you have the heated portion, which sits on top, which has 3 thermocouples. We also have a middle section here that also has 2 thermocouples on it. And then we have the cooling section at the bottom that also has 3 thermocouples. So if we're using this setup, we would have a total of 8 thermocouple readings. This is not the setup that we're going to be using today, but let me just walk you through so you can have an understanding of what's going on. What we have here, we have heat sink compound, and this is applied to the surface of the sections, which promotes the conduction process. Then we have our measuring cylinder, which we'll use to calculate our flow rate. In other setups, the machine is configured in such a way that we could actually connect a digital flow meter, which would be controlled from the computer also. However, today we're not doing that. So today's experiment, our flow rate should be at 1.5 liters per minute. And the measuring device that we have, the maximum on it is 250 milliliters. So we'll have to do some conversion to figure out what, how to get our actual flow rate. So what's happening that there's cold water or tap water coming in, and it exits through this tube. And what we'll do is to catch whatever water is exiting through the tube in our cylinder, along with a stopwatch to figure out our flow rate. Now, as you can see, all the thermocouples are connected to the computer box. So that will give us direct temperature, instantaneous readings on the ARMFIELD software. Now, let's get into the experiment for today. So what would happen, we're gonna remove this section, because this is not the section we're using. We're gonna be using this section. I've already applied thermal paste to it. So we're gonna sit it down on top, put the heater on top also, and then we're gonna clamp it down. Now bear in mind that my flow rate is already configured, and I can show you exactly what's happening over here. So I have a sink here, and this is our return hose, and as you can see, there's water running out, and it's at the desired flow rate. Now back to our experiment. So now we are configured to begin, with the exception of removing thermocouple 4 and 5, which belongs to this unit. So we'll just go ahead and put that here. So what we have here, we have our heated portion, our section in the middle, and then we have our cooling section. And of course, as I said, we have 3 thermocouples on the heated, on the cooling section, and 3 thermocouples on the heated portion. And they'll be numbered 1, 2, 3, 6, 7, 8. Now, what would happen is that we would go ahead and turn to our ARMFIELD software. Now this allows us to control the HT11C. So in today's experiment, we're going to be bringing the temperature up to 3 different levels. So our first level, we're going to bring it up to 6 volts. So we can't get it exactly on 6, so we're going to put it to 6.2, if you can see here. So it's at 6.2. And what will happen, you'll see our temperature readings on this side. So you'll see temperature readings T1, T2, T3, T6, T7, T8. And in the middle here would be our section that we added to the rig. Now, we would actually allow the system to stabilize for roughly 5 to 7 minutes. As soon as it is stabilized, we would hit go. And when you hit go, you go to your tables and it would indicate to you all the thermocouple readings. So it's showing you T1, T2, T1, T2, T3, and of course T6, T7, and T8. Let's get back to the diagram. So our next reading should be 9 volts. So we'd go up to 9 volts. That might be a better angle for you guys. So we'd go up to 9 volts. It won't go exactly on 9 right now. We have 9.1. And of course, we allow this system to stabilize for 5 to 7 minutes. And again, we would hit go again and go to our tables, and we would actually get our thermocouple readings 1, 2, 3, 6, 7, 8. We would go back to our main screen and of course do our last voltage reading. So we'd bring it up to 12 volts. Perfect. And of course, we would allow the system to stabilize, take readings, and so forth. And of course, as you know, the higher we go in voltage, the higher the temperature would be, of course. So that would basically conclude our experiment today. So again, we have our HT11C linear heat conduction rig, and today set up, we have our heater on top, our 1-inch insert in the middle, and our cooling section. And all our readings were gathered through the ARMFIELD software. And our flow rate was 1.5 liters per minute. And of course, as I explained earlier, we don't have a digital flow regulator on our rig, so we had to use a measuring cylinder. And our measuring cylinder, the maximum reading is 250 milliliters. So we had to do some conversion, and I'm assuming that you'll be doing those conversions to give me equivalent flow rate, so we could get the desired results. Now at this point, this experiment is over. Any questions, feel free to contact your professor, Dr. Whitworth, and thanks again.